Let's discuss about forward propagation. As we can see here, we have some input layer. X1 and X2 belong to the input layer. H1, H11, H12, H21 and H22 are two hidden layers, and then we have Y, which is the output layer. Here we have biases, which is B1 at hidden layer 1, B2 at hidden layer 2 and B3 at hidden layer 3. These are the values of all the inputs. We have X1 and X2 equals to 0.3 and 0.5. The target value for Y is 0.5, and as we can see here in this diagram that every node is connected by some sort of a weight denoted by omega 1, omega 2, omega 3, omega 4. What happens is when we are calculating the effect of our inputs at any layer, we need to consider the weights so that we can have an optimal amount of we can give optimal amount of preference to both the inputs. For example, if we consider H11 node, we are having omega 1 from X1 and we are having omega 3 from X2, which means that the weightage or the importance given to both of the inputs is different because the weights omega 1 and omega 3 are different. So here in this case we have 10 weights and we have 3 biases. These are the values of all the inputs, of all the biases B1, B2, B3 and all the weights segregated by layer. This is for hidden layer 1, this is for hidden layer 2, this is for output. And our target value of Y is 0.5. The formulas we use here are for any node H11, for example, is equals to omega 1 X1 plus omega 3 X2 plus B1. Here we can see for H11 we have both the inputs contributing to H11. X1 with the weightage of W1, which is what we have considered here, omega 1 multiplied by X1. We have X2 with the weightage of omega 3. That is exactly what we have considered here with omega 3 multiplied by X2, and then we have simply added the bias at our hidden layer 1, which is plus B1. Similarly for H21, now we have come to hidden layer 2. For H21 we have H11 contributing with the weightage of omega 5 and H22 contributing with the weightage of omega 7. Here we do not consider H11 or H12 directly, we take their sigmoid function. Sigmoid function is a type of an activation function which we will study about later. Here at H21, since it belongs to hidden layer 2 and the bias corresponding to hidden layer 2 is B2, which is why we have added a bias B2. This will be done similarly for all the nodes. Another formula that we use is sigmoid function. Sigmoid of anything is equals to 1 upon 1 plus e raised to the power minus of that anything. In this case, sigmoid of theta is equals to 1 upon 1 plus e raised to the power minus theta. And in this case, we are calculating error by just simply subtracting our sigmoid of our value y from the target value and taking the modulus of it. This is the simple error method. There are a lot of error methods like mean square error and root mean square errors, which we will study about later. Here is the calculation. We have done nothing, just put all the values given here into the formulas over here and using sigmoid function given over here. Using that, we have calculated all the values. H1 came out to be 0.68, which means sigmoid of H11 using this formula came out to be 0.66. H12 came out to be 0.76 and sigmoid of H12 came out to be 0.68. Now, after calculating all of this, Y came out to be 0.7882 and sigmoid of Y came out to be 0.687. Now our Y target or target value of Y was 0.5, which means our error is going to be sigmoid of Y minus Y target modulus, which is equals to 0.187, which means we have the error percentage of 18.7%. Now this error percentage can be reduced by using back propagation method, which we will study next.